Yep, in this session, I'm just gonna cover how to do the virtual wind testing in SolidWorks. As you could see, I have created the model as per the reference dimensions. Okay, now I'm gonna run the simulation, flow simulation inside it, that is internal flow simulation. These are the assembly components, and I have added the LEDs, inlet and outlet, and this one, and I have placed this cylindrical extrude rod over there for validation purpose. Okay, how the flow gonna takes place from here, and how it gonna distribute on the circular cylindrical object. Let me switch to flow simulation here. Okay, and already I have created the project. I'm gonna explain that one later. Now I'll create the new wizard. So this should be project 2. Any system you can set it up and keep it like this. The flow should be internal. Okay, and then gas, I need air. I'll add it up, and I'll keep the adiabatic as it is over there, and I'll keep all the parameters here as default. Once that is done, the computational fluid domain will be created. This is fine for me. I'll simply hide this for now. And then I need to apply the boundary conditions. Let me add inlet velocity from this inlet let phase 10 meter per second. Is that fine? Yep. For this it's okay. And I need environmental pressure should be defined on this phase. I'll switch to this, and environmental pressure, I'll select this. I'll click OK. Okay, once you define that too, I need to define the goals. I'll go ahead with the global goals. You can select drag force, as well as if you want velocity also you can select on average and maximum. And then equation also you can define if you have the equation. I think it is not available. You can copy it. That is rho v square. The formula is 2 times of force divided by rho into v square into area, CD, coefficient of drag. And now for the equation, let me take it from the reference. Okay, just a minute. I'll close and switch back to project 1. From here I'll edit this. This is my equation. I'll copy this for now. Okay, project, I'll select the equation goals, I'll add it, but here I need to change this force. Here I need to define the goal. I'll click on this add goal. From here drag force I need and add it up. Okay, and I'll explain the equation of this. 2 times of force into divided by density into velocity square into area. Okay, this the frontal area I need to change here. For that I'll simply select it. Okay, I could do to check the frontal area is just go to evaluate and measure. Area is this much. It should be in meters. Point 0.13. .13. I think it's overall area, right? 0.1352. The frontal area I need to consider. Okay. 0.06. I'll keep this much for now. We are done with that. The mesh, I'll simply go with global mesh. I'll refine it to level 7. Complete copy. I don't want to change anything over there. Now I'll simply run this by just selecting the default conditions. Once you do that, it's gonna load up the solver and the given boundary conditions. Can even define the float while running this ready. Once the solver starts, I need force and the equation graphs. Start it. Until the result converges, it will keep on solving the iterations, and finally it's gonna give the results. Yep, once we are done with this, you can see the results got converged at these values. The CL value is on an average of 0.027, that is 0.03. The drag force is 0.05 Newton. And for the results, I'll simply switch back to the project one so that I can explain these results. I'll load all. Here you could see the first class. We're gonna explain about the pressure float, how exactly it is distributing on it. Okay, and the next one is velocity float. As you could see how it is acting on that particular cylinder. And the next thing is surface float on these locations, the pressure as well as the velocity floats. And this is about the flow trajectories, how the flow is taking place on that particular profile as well as the location. Well, this is all about this project, so I hope this might help you to deal with SOLIDWORKS simulation, that is flow simulation. you have any queries, you can revert me back. Thank you. Stay tuned.